3. Also 2 prime numbers multiplied to give it. Next one, 8. Can I make it just by multiplying prime numbers? 4 times 2, yeah, but there is another way. 2 times 2 times 2. Okay, for those of you who know your index form, 2 to the power of 3, that would be called. Okay, 10. Oh, 9 is the next one, isn't it? That's 3 times 3, also both prime. So I can make them all so far with just prime numbers. 10, 5 times 2, that's prime. Prime times prime. 12. 2 times 2 times 3, yeah, 4 times 3. Okay, is it that all composite numbers can be made with multiplying primes together? Yeah, it is. You can keep going with this pattern. 14 is 7 times 2, 15, 5 times 3, 16. A lot of 2's times each other. Yeah, 2 times 2 times 2 times 2. Okay, right. So we can split any composite number and form it by multiplying primes together. It's kind of interesting. To do this with larger numbers, we use something called a prime factor tree. Which helps us get to a result like this without having to overthink it. So if I have a number like 48, and I want to write it like this, this is called product of its prime factors, because product means to multiply. Factors means numbers that divide in. So product of prime factors. And they're prime numbers. So 48, I just think of any two numbers. They don't have to be prime that multiply to give 48. Anyone give me two numbers? Harry? 6 times 8. Neither of those are prime numbers, but that's okay, because I'm going to split those up because I know that 6 is 2 times 3. And that's prime, and that's prime. What's 8? Well, I can do 4 times 2 if I'm not sure, and then do 2 and split the 4 up into 2 times 2 times. So, I can write 48 like this as a product of prime factors, multiplying prime numbers, by just picking all these prime numbers at the end of my tree. 2 times 2 times 2, how many? 1, 2, 3, 4 times 3. 2 times 2 times. And that multiplies to give 48. You can test that. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. Yeah.
Do we write that down?
Ah, that's a good example, yeah. Yeah, let's take that one down. Just do this prime factor tree. You don't need to. No, it's okay.
What we write down?
How this. Yeah. So a question in the exam could be draw a prime factor tree.
So all factor trees have to finish in like
At prime numbers, yeah. Yeah. So is there a reason we stop at primes? Why don't we go 2 times 1 here? Because we'd have to go 2 times 1 forever. Yeah, that's an infinite pattern. So once we have primes, we don't use the factors anymore once we hit it. Yes, Collins. Yeah.
Can you put 2 to the power of 4?
Yeah. Times 3. Yeah. Okay, I'll do another one. Let's pick another random number between. Anyone pick a number between 1 and 100? That's composite. It's composite. Caleb? 76. Okay, we're going to do 76. Our second example of a prime factor tree. So to start off with, I got to think of two things that multiply to give 76. Anybody? Gavin? Have the answer in your head. Harry? 38 times 2. Okay, yes. So I noticed, or maybe Harry noticed, that this is an even number, so it ends in a 0, a 2, a 4, a 6, or an 8, and that can be divisible by 2. So these two numbers multiply to give the one above. 38, then I can think about splitting again. 38. Now, Kevin. Oh, he did it again. 19 times 19? Yes. Remember, it is multiplication. These two numbers multiply to give the one above. They do not add, they multiply to give the one above. Okay. 2 is prime, so that's okay. 2 is prime, so that draws an end to those branches. 19, Caleb? 2 times 8? That's 16. 19 is prime, yeah. 19 is prime. So we've hit all our primes. So 76 is 2 times 2 times 19. Okay.